This is page 76. So the test was supposed to be today, but tomorrow's Friday, and I thought instead of taking the test today, and then tomorrow starting a whole new unit, we will just go deeper in this unit today and review, and then take the test tomorrow, so then you don't have homework over the weekend.
That's wonderful.
Okay.
Thanks.
So that's what we're doing. So the front of this paper is wrapping up your understanding about right triangles, okay? Let's refresh your memory on some stuff. Remember that the angles in a triangle always have to add up to 180 degrees. Now, having said that, let's come right here and let's draw a right triangle. So all three angles have to add up to 180, right? Are you with me? What does the little square mean?
90 degrees.
Okay, that means 90. So if one angle is a right angle, which it has to be if it's a right triangle, then the two smaller angles would have to add up to what?
90 degrees.
90. So the relationship is, in a right triangle, all three angles add to 180 every time. In a right triangle, one angle measures 90, right? So because one angle measures 90, this is really important, then the two other angles have to add to 90. That's how you get the 180 total. You with me? Okay, so the visual is, this right here is 90 degrees, and then this angle and this angle total is also 90. Y'all see that? Take your AirPod out. Okay, now go back and recall a vocab word from way back. Two angles that add up to 90 are called complementary. With an E, not an I. Okay, so now what we're going to do is we're going to look at what happens. There's a relationship, there's a pattern that exists between the two angles of a triangle, and it's all because they add to 90. Okay, there's a relationship. All right, so that's what this is, easing us to that relationship. Instead of me just flat out saying, hey, here's the relationship, now run with it. I'm going to get you there. If we have a triangle, LMN, so the three angles are L, M, and N. It says angles M and N are complementary. That's huge. That's really important right there. That's saying to, oh my word, stand by. That's saying to you that, hey, when you go to draw this triangle, if M and N are the complementary ones, then L has to be the right angle. That's what it just told you by saying that. Do you understand? All right, so we're going to draw a picture. I don't know how that happened. I changed to green. We're going to draw a picture. L has to be the right angle. Doesn't matter where you put M and N. Now we're going to read what it says. Really didn't even need the picture here, but I'm just drawing it to help you. It says angle M measures 27 degrees. Find the measure of angle N. What? I heard it. Why? Yeah. So if M is 27, then N has to be 90 minus 27, which is what?
63.
63.
That's easy money.
Okay, do that one. The next one.
Number 2.
If angle Q is 33, then angle S is going to be what?
57.
90 minus 33, which is 57. Okay, now let's go to the next question. In triangle TUV, angles U and V are complementary. They just discretely told you that T must be the right angle and U and V are the two quarter angles. So we're going to sketch a picture. T goes at the right angle, U and V are the other angles. They tell us that sine of U is 2/3. What's the formula for sine?
Opposite over hypotenuse.
Okay, if they're giving you the trig ratio, they are giving you, as a fraction, then they're giving you two sides of the triangle. So you have to label it. So if they say, hey, sine of U is 2/3, they just told you, because it's sine, that the opposite of U is 2, and that the hypotenuse is 3. So you label your picture. So the hypotenuse is 3, go to U, and then opposite would be 2, right?
It's not over now.
Yeah.
Now the next question says, so what's cosine of V?
So it would be 2, 3. 2 over 3.
Cosine is adjacent over hypotenuse, and it would be
2 over 3.
2 over 3. I want you to do example 4.
We don't have to solve it.
Didn't ask to solve.
I said what it is.
Well, but we found it. We found the fraction.
I'm just asking, like, a question. That's how you get smarter.
So you would be dumber.
You're doing number 4.
Dude, this is so easy.
Draw it out. So we have triangle XYZ. They tell us angle X is the right angle. So I'm going to put my Y and Z like that. And then they tell me that cosine of Y is 8 over 11. What sides did they just discretely give me?
Side Y and the
Well,
adjacent and the
they just gave me the adjacent and the hypotenuse. Adjacent to
Y.
Y. Okay, so adjacent is 8 and the hypotenuse is 11. Then it says, what is sine of Z?
8, 11.
Sine is opposite over hypotenuse. Right? Okay. What did you notice in examples 3 and 4?
Well, they're the same.
Did you notice in 3 and 4 that your answer was the same as what they gave you? You see that? This is really important. There are 2 of these on the test tomorrow. Did you notice the answers in 3 and 4 were the same fraction that they gave you to start with, right? Okay. So what did you notice in 3 and 4? The sine of one angle equals the cosine of the other angle. Which means, drawing an arrow, which means sine of angle A is equal to cosine of angle B if angle A plus angle B adds to 90. That's what it means. There's a relationship between the 2 angles in a triangle. And the relationship is that the sine of one of them is going to be the same as the cosine of the other one.
Oh.
Let me show you the visual. Look over here. Look over here at this one. They gave me sine of u, which is opposite over hypotenuse, correct? Okay, and then it asked me for cosine of v, which is what formula? Adjacent over hypotenuse. Do you notice that I ended up highlighting the exact same ones? That's the relationship. The sine of one angle is always the same as the cosine of the other angle as long as the 2 angles add to 90. Okay? Which takes us to the next 2 questions, which is just like what's on the test tomorrow. Without actually using your calculator, the sine of 24 is going to be equal to the
66.
And that's because the sine is equal to the cosine as long as the 2 angles add to what? 90. So if I say to you, what's the sine of 24 equal to? You would say to yourself, okay, 90 minus 24 is 66. So the sine of 24 would be equal to the cosine of 66.
So it's number 10.
No, it's never 10. There's no relationship with tangent at all. And that's because tangent is opposite over adjacent, where if you go back to when I was highlighting in green, it wouldn't work out nice. All right, so what would be equal to cosine 70? Sine 20. Because 90 minus 70 is 20, and it would be the other, like if I say the sine, then it's the cosine. All right? In triangle DEF, angles D and E are complementary. If cosine of D is 3/5, what would cosine of E be? Now this is slightly different. Notice it was the same trig function. So this is just a, can you go back and draw a picture? D and E are complementary, so F is your
Well,
right angle.
it'd be x over 5.
But you got to find it. What do you use to find the missing side of the right triangle? Pythagorean theorem. Ow.
Well, oh, you got the Pythagorean theorem.
So label your picture. Cosine is what formula? So this is the adjacent and this is the hypotenuse. Adjacent to D, right? So go to D. Your hypotenuse is 5, and then right next to D is 3. But they want cosine of E. I don't know what's next to E, so I have to use the Pythagorean theorem.
Well, good thing this is a Pythagorean triple, and it's going to be 4.
If I had candy, I'd give it to you right now. Thank you. Yes. Oh, never mind. You already ate Jolie's candy, so you're good.
Yeah.
This is a Pythagorean triple. It's a 3, 4, 5 triangle. Do make sure the 5 is on the hypotenuse before you run with 3, 4, 5. I'm just saying, like, what if this was 5 and this was actually blank? It would not be 3, 4. So be careful. Make sure the 5 is actually the hypotenuse. So, what's cosine of E then?
4 5.
There you go. All right.
Amen, Jesus.
Look at this next question. What if right triangle ABC is isosceles?
Which means 2 sides are equal.
That means 2 congruent legs, right? It means that this is equal to this. Yes?
Right.
Okay. Well, then what would the measures of angles A and B be?
45.
45.
Why?
Because 45 plus 45 equals 90. And they are complementary angles.
Which,
How do you know they're equal?
because,
Because 45 plus 45 equals
No, how do you know they're equal?
Because it's an isosceles.
There you go. Y'all go back to when I said about isosceles and equilateral triangles. The number of congruent sides dictates the number of congruent angles. So if there's 2 congruent sides, there's 2 congruent angles. If it's a right triangle, then they have to be 45 because they have to add up to 90. So find the measures of A and B. Angle A would be 45. Angle B would be 45. And it's because it's isosceles. Now the next question says, now tell me what tan of A and B would be. Well, what's the formula for tan?
opposite over adjacent.
Okay, tan is opposite over adjacent, right? Which means tan uses what part of the right triangle? The legs. Tan uses the legs, right? Go with me? I need y'all to get here. This is one of those, instead of me telling you the relationship, I'm hoping to kind of guide you there and then someone will say it. Tangent uses the legs. We have an isosceles triangle, which means that the legs are congruent. Does it matter that I don't know what they measure? No. If this is x, then this would also be x. Okay. So, if I was to find tan of A, what would the fraction be? 4. X over x. What's anything over itself?
1.
Back up. Anything divided by itself?
1.
1. Yeah, it's okay. So, if tan of A is x over x, and anything over itself is actually 1, then tan of A is 1. Regardless of what the sides are, they could have been 5 and 5, 10 and 10, 11 and 11, ugly and ugly. You would set the ratio up and it would divide to be 1. So what's tan of B? Yep. The point of this question is to show you that if you ever have an isosceles right triangle, number 1, the 2 angles are 45. Number 2, the tan of either angle is the number 1. And then the last part is